Welcome to this course of data science. So let's start by defining data science. So how will we define data science basically? So it is an amalgamation of different scientific methods, algorithms and systems which enable us to gain insights and derive knowledge from data in various forms. Basically, data science is an application of statistical algorithms and statistical methods which had already been developed in the yesteryears, say in the 1980s and in the 1990s, but we did not have the computing power or application ability to realize the benefits of those methods. With the advancement of computation abilities, we are able to leverage those methods that were developed in yesteryears. So, without getting into too much theory, let's start the practical side of it. So, what we'll do is we'll start with an introduction to R, and we'll discuss about R programming, the objects and classes, various code qualities, the packages, how to import data, how to do mathematical operations, and how to play with strings, functions, how to visualize data in R. So let's start with the basics of R programming. So I'll be using R Studio for this course. So to clear the screen in R, press Ctrl L. So it will help you clear the screen. So the top left panel is the editor. The lower left panel is the console. The top right panel constitutes of environment tab, which refers to the console environment and lists in detail every single symbol that has been defined in the console, and history tab, which lists every console command that was ever executed. And the bottom right panel is miscellaneous and contains initially 5 separate tabs, namely files, plots, packages, help and viewer. To install RStudio, you can go to rstudio.com and you can press this download button here. It will take you to the download page, and here you can choose the version that you want to download. So if you're a student, download this RStudio desktop. If you are from corporate or a professional who needs more support from the R team, then you can go for licensed products. So for the time being, I have downloaded RStudio desktop, and this is what RStudio looks like. So in order to increase the font size, you can go to view and you can zoom in. So I'm just zooming in order to make it more clearer. Okay, I think this is good enough. So let's start by writing very basic R statements. Say X is equal to 324, Y is equal to 783, Z is equal to 987, print X plus Y. It will give you the sum of X and Y. So X here is an object, so is Y, and so is Z. The objects hold a certain value. So based on the kind of value an object holds, their data type is decided and assigned. Data type in R is known as the class of an object. In order to comment, you can use hash. For example, hi, welcome to this R course. And this operator, that is bracket and hyphen, this is called the assignment operator in R. Now, for instance, I want to find out the class or data type of X. Then I'll type the function class X, and the system shows numeric. There are other data types as well, that is, there are other classes in R as well. For example, if I say B is true, and if I see the class of B, it will become as logical. If I create another object called C and assign it to L, and if I see the class of C now, it will be integer. Then we can have a complex data type. Say I am defining an object called com, in which I'll give 4 plus 3i, and now if I see the class of com, it will be complex. Similarly, we have character data type or class. Say if I have str, this is our introduction, then we see the class of str, it will give character. And finally, we have another class in R called raw. For instance, if I create a variable var1 and store say insane coder in it, then if I see the class of var1, it will be character. However, I can convert this character data type to raw data type by using, say in var2, I can use the function char2 raw and the variable. So this is a good demonstration to tell you that R is case sensitive. So char to raw small t is not equivalent to char to raw with a capital T. So the problem in our statement was, in our command was, that this has to be capital. And now if you see display var2, then it will give you the raw bytes in which it has been stored in the memory. So the raw type is basically intended to hold raw bytes. A raw vector is printed with each byte separately represented as a pair of hex digits. So these are hexadecimal digits basically. Now I have reached to the bottom of the console screen, so I don't like so much cluttered space basically. So one thing to notice, every command or every object that I have declared has been stored in the history of RStudio. So if you see, we started from declaring X today from here, and it has stored everything that we have declared or typed on console since then. So now I'll clear the screen. So if you remember, in order to clear the screen, what should we do? If your answer is Control L, then congratulations, you are correct. If not, never mind. In due course, you will also remember what is the command to clear the screen. Anyways, so I've already said that R is case sensitive. So if I say give various subjects, math, the score in math is 89, score in say English is 78. So if I want sum of math plus English, and say I have another variable, some var math plus English, and if I print sum, and if I print sum underscore var, they are two different values. Why? Because what RStudio has done is they have taken a previously declared variable English, which I might have declared in my past practice, which had the value 12, and it has added it to the value of math, which is 89, and given me a result of 101. Had English not been defined, it would have given you an error stating that object English not found. For instance, if I say Prometheus, I'm pretty sure I have not declared this anywhere. So if this was 32, now if I want to print math plus Prometheus, then the system is going to give you an error stating that object Prometheus not found. Now let's talk about objects. So in any programming language, we use various variables to store information. Variables are reserved memory locations to store values. This means that when you create a variable, you reserve some space in memory. An R object can be a combination of type of variables, functions, or data structures. So objects in R are like vectors, lists, matrices, arrays, factors, or data frames. So let's have a look into that. So before that, let's clear the screen. Control L is the command. Hopefully you have learned it by now. Let's talk about vector first. So say I declare a variable var1 which would contain elements from 1 to 9, and if I print it, it is 1 2 3 4 5 6 7 8 9. Now what if you had to type it? Say, will the system accept something like this? No. So how will you assign this kind of a value to a variable? So to do that, you will have to use the function C and then type whatever you had typed before. Now if you print it, it will print the numbers that you have stored. So C is just a generic function which combines its arguments basically. So what is a vector? Vector is a sequence of data elements of homogeneous data type or homogeneous class in case of R. Elements in a vector are called as components, and vectors can be created in many ways. Two such methods I have shown you, and you can further create, say, text 1 is welcome to Insane Coder. So we can check if this variable is vector by the function, by using the function is vector and text1. So it is true. Had it been heterogeneous, which is the case in some objects, which we will discuss in due course, is.vector would have returned false. So you can have any kind of class, but the class should be homogeneous. So even 5 plus 3i, 7 plus 2i, if we check the class of comp1 variable, if we check whether comp1 variable is vector or not, the system is going to return true. So we can have vectors of all classes, all kinds of classes. It's a good time to revise the kind of classes that are there in R. So if you are wondering, the classes are numeric, integer, character, complex, raw, and logical. If you got them right, congratulations. So let's move on to the next topic, which is how to seek help from R. So R has an inbuilt help facility. To get more information about any specific function, for example, I want to get more information about vector, we can type in help and the function name. Say help vector, and I'll get a help which will be displayed in this window. Okay. Instead of typing help, we can just type a question mark and we can write vector. It will end up in the same result. Say print. Now there is another function called example. So in order to use this function, you can write example and function name, say vector, and it will give you the examples of vector. Basically, you can scroll up and see what the system has given you. So I just cleared the screen. So next, let's talk about a list. So before talking about list, let me show you what a list looks like. So for example, if you say lst, you give the name Jonathan, give the spouse name Mary, say number of children, is equal to 2, 2, and say ages of the children is C, 4, 8 and 12. So this is an example of list. If you print it, it will print the name, spouse, number of children and the ages of the children. Sorry for the spelling mistake, but that doesn't matter. So what matters is a list is an object consisting of an ordered collection of objects known as components. So name, spouse, number of children, age of children are components of the list named LST. The components need not be of same type. So if you remember, in vector, it had to be homogeneous, but in list, it can be heterogeneous. So in this particular example, the list contains the numeric class and character class. So if you check the class of this object, it will give you as list class. There's another command to check if an object is list, which is.list. So the return will be true. There is another very interesting function called str. So str basically will give you the components of the object. So str lst will give you the list that you just created along with the classes. So next, let's declare another variable str. Say we are declaring 1, 2, 3. Now if you see the class of str, it will give you as character. Now you can convert this object into a list using the command as.list. So as.list, give str, it will get converted into list. You can store this object in any other variable and then work accordingly. So let's clear the screen before discussing about the next object, which is factor. Let us start with an example. Let's create a variable var1 and store the values 1, 0, 1, 0, 0. 1 0 1 0 1 and 1. So we have a variable var1 which is string of numeric characters 1 and 0. So let's create a factor of var1. Let's create a variable named var and let's factor the variable that we just now created and store it in var. Now if you want to check whether an object is a factor, use the function is.factor. So let's check if variable 1, that is var1, is a factor. So the system returns false. Let's check if var is a factor. Yes. Now if you print var, it will give you the same thing and certain levels. So a factor is a vector object used to specify a discrete classification or a grouping of components of other vectors of the same length. Factor variables are categorical variables that can be either numeric or string type. R provides both ordered and unordered factors. So we'll discuss about what ordered factors are, what unordered factors are. So let's create a big variable. Basically say let's create a variable a and let's store certain values in it. Say Sachin, Kohli, Pace, Sania, and let's randomize it now. I'll just paste randomly here. This should do. Let's store this variable and let's check if this is a factor. Is factor a, system returns false, and let's create another variable b and store it in factor format as factor a. Now let's check if b is a factor. Yes, true. And let's print b. It will print b and then it will also show various levels. We can use the command table a to see the frequency of individual items in the list. Next, let's discuss about ordered factor. In an ordered factor, logical flag is set to determine if the levels should be regarded as ordered or not. So let's consider a vector named height. And then let's create more elements in it. this should do. So let's factorize this. Say height dot f is factor of height now. If I print this new object, then I'll get levels as average, short and tall. So this is an unordered factor. We can have an ordered factor by using, say, let's create another variable, height dot o, and let's factorize height again, and let's define the levels equal to c short, average, tall, and let's say that this is ordered equal to true. Now if you print height dot o, it will print in an ordered fashion and it will give you the order of the list. Let's clear the screen and move on to our next topic, which is matrix. So matrix is an object which can be used for a variety of options, and it is a very important object with respect to data science. Basically, matrix is a collection of data elements arranged in a two-dimensional rectangular layout, and it is a collection of vectors of the same length. There are multiple ways to create a matrix. The first is to create using the matrix function. So let's create a variable temp city, which will have the temperatures of any given city or place for a period of, say, 20 days. So these are 10 temperatures. Let's copy them. Let's paste them. So now I've got a list whose length is 20. Now what we can create is, we can use say temp city, we can create a matrix out of it. Mat is equal to matrix, give the data, which is in this case temp city, then give the number of columns that you want. Say I want 5 columns, whether the elements will be arranged in row wise or column wise. If you put by row false, then it will be arranged in a column wise way, and if you put by row as true, then the elements are going to be organized in a row wise way. And we can also give the names of our rows and columns. Say let's give it as list R1, R2. So you'll have 5, you'll have 4 rows basically. And we can have column names. Column names as C1, C2, C3, C4 and C5. Now if I print this, we'll get a matrix of 4 rows and 5 columns. Now in many cases what we are going to have is like we'll have row wise data. Say when we are processing a list of Excel files or something, then we would have row wise data. For instance, if we talk about marks of a student in a class, say Shyam has got some marks are out of 100. Shyam is a bright student, so let these be his marks. Next, let's have another variable, Nosheen. She will have marks like 76, 90, 91 and 67. Let's have another variable named Anirban, 78, 76, 75 and 80. So we have 3 variables here and we want to create a matrix out of it. So how are we going to do it? We will create a matrix, say student.matrix, using the functions column bind or row bind. So if I bind it using R bind, so it will be Shyam, Nosheen and Anirban. Now if I print it, it shows Shyam, Nosheen, Anirban. These have been created in a matrix in a row wise manner. If I wanted them if I wanted to create a matrix column wise, then we would have used .c, the function cbind. Anirban. So now if I print this matrix, this has created a matrix in a columnar way. So one thing to note here is that once a matrix is created using R bind or C bind, then we can convert it into the other respective kind using transpose or T functions. So say if I print T of stu.mat.c, I will get stu.mat and vice versa basically. We can use the functions call names and row names to view or modify the columns and row names of a matrix respectively. So after clearing the screens, for instance, I want to give call names to our stu.mat variable. So in order to do that, I have to write call names stu.mat and then we can assign call names here using C function, English, Hindi, Bengali and Telugu. So now if you print stu.mat, you will get the column names as well. Similarly, you can use row names to rename rows of a certain object. Next, let's discuss arrays. So an array is a R data object that can store data in more than 2 dimensions. So if you remember, while introducing matrix, we said that matrix is a data object that can store vectors in 2 dimensions. What if you want to store something in multiple dimensions? So in that case, you have to use arrays. So to check the syntax of any object, you can just type in str array, and the system is going to give you how this function is to be used. Similarly, say str print, str call name that we just used. So if you have any doubt regarding the syntax of any command, then you can use str, that function name or command name, and then the system is going to give you the syntax of that command. You can also use help function and example function as explained earlier. So I'll clear the screen. Now let's create an array. Say our array name will be arr1. Let's create it using array function. Data is equal to 1 is to 24, and now you can give the dimensions of the array, which is 24 can be like 2 into 4 into 3. You have your array 1. Now you can print it. So you have a 3-dimensional array. So finally, let's discuss about the most interesting object of R, data frame. So what is a data frame? Data frame in R has 2-dimensional properties similar to a matrix, but it can contain heterogeneous data. So if you have some data that you're working on which contains homogeneous elements, then it can be worked upon using a data frame or a matrix. But if you have heterogeneous data, then you cannot work on heterogeneous data using a matrix object. You will have to use data frames. So data frame is like a list with components as columns basically, and the components of a data frame must be vectors. That is, they should be numerical, character, or logical, or numeric matrices, lists, or other data frames. And vector structures appearing as variables of a data frame must all have the same length, and matrix structures must all have the same row size. So if you want to see the syntax of data frame, just type in str data.frame, and the system is going to give you the syntax of data frame. So let's create a data frame. Let's create two variables, namely subjects, and let's store values in it. English, Hindi, economics, physics, and mathematics. Let's create another object called marks, in which we'll have, say, marks of it. And then in order to create, say, my marks, in order to create a data frame called my marks, I'll use data.frame, and I'll give the variables that I just now created. This will create a data frame my marks. So now you can check the class of my marks. It is data frame. Next, we'll consider the matrices that we had created earlier, stu.mat. This is a matrix, and if you see the class of this matrix, then you will see it as matrix. Now if you want to convert this matrix into data frame, then in that case you can use the command as.dataframe. So for instance, let's create stu.mat.df function as.dataframe, and let us give the variable name. And now if you check the class of the newly created object, it will be data frame. And if you want to print it, you can print it. It will give you the same data. So this was homogeneous data. So this you can use either matrix or data frame to operate on this data. However, if you see my marks, if you print this, this is heterogeneous data in the sense it has character as well as numeric data types in it. Now, in order to describe the data that you have, you can use this function str.mymarks. So if you notice here, then subjects has been stored as factor object. If you don't want this to happen, then what you need to do is say my marks will be data.frame marks and subjects. This again, if you see, will store it as factors. If you don't want this to happen, then you need to write this extra parameter strings as factors. So at the time of data frame creation, you need to write strings as factors equal to false. Now if you see the description of my marks, it will be character. This is one important thing to keep in mind. Let's clear the screen now. So say if you want to see the names or call names of a certain object, then you can use these commands. And just like demonstrated in an earlier part, you can even rename the column names and row names of a data object. Next, let us discuss about not applicable or NA values. So there would be multiple times in which we would get a data set in which there would be values that are going to be missing. So what would happen in such a case? Let's create a data frame with NA values first. Say A is equal to 323 NA 3 and NA, and B is C A B NA D and finally E. And say we have another field C, which is again numeric, but with bigger numbers and 12. Let me create a data frame using data.frame command and A, B and C, and strings as factors is equal to false. So if I print df1, it will give me NA values basically. So now in this case, if you want to say take a mean of column A, then we say mean of df1 $A, then the system is not going to return you any mean. Similarly, if you want sum of df1 and column A, then system will return you NA. Same would be the case if you do it with column C. So how to deal with this data? For instance, if I write the same command mean of df1 column A and I use na.rm is equal to true, then the system is going to ignore the NA values in that particular column and give you the mean of the remaining values. Similarly, you can use sum or any other function for that matter to deal with the NA values present in a data frame Then you can use is.na function to check if there are NA values and where those values are. So is.na, our data frame, will give you this output. So wherever there is an NA element, it will be marked as true, and if it is not there, then the system is going to return false. Now, if you want to completely ignore the rows which have NA value, then you can use na.omit, say in df1. So it will only return you the values which do not have NA values in any of the rows, basically. So that marks the end of data frame topic. Let's clear the screen, and now let's talk about manipulating objects. So till now, what we have learned is we have learned classes, which are nothing but the data types in R, and we have learned various kinds of objects like vectors, lists, factors, matrices, arrays, and data frames. Now, how do we manipulate these objects? Obviously, if you are working for long times, you are going to forget the object names that you have created. So in order to see the object names that you have created from the start of this session, basically, then you can use this command objects. You can use another command which will give you the same result as ls. Now, for instance, I want to edit a data frame. Basically, let's edit, say, df1. So if I give this command, then the system is going to open a data editor in which I can give or write things according to my requirements, and then I'll close it, and the system is going to update that object accordingly. So the edit function works with any type of object, be it vector, list, matrix, data frame, or factor. Let's create a new variable, new var c. Okay, now I want to append more values into it. Then what I'm going to do is I'm going to append, and then say I want to append this particular variable, and I want to add 99 after the fifth element. Then after the fifth element, which is 11 in our case, the system has added 99 into the variable new r. Say you have a variable x with 10 elements from 1 to 10. If you print x, you will get the numbers. Say you want to print it without number 7, then you can print it like this. If you say if you give the command x square brackets minus 7, the system is going to remove 7 from the list of elements in x. What if you want to append in this? So what you're going to do is x, now c is used for concatenating things, basically, and you can write 11 to 20. Now if you print x, it has appended at the end. Now if you want to get the working directory in which you are working, you can use the command get wd. It will give you which directory you are currently in. If you want to set the working directory, say I want to set it to D drive in my system, then I can do it like this. So now if I get the working directory, I'll get D drive. Now, for instance, I want to save things now, save all the objects. Then I'll just use this command save.image, and I'll give the file name as, say, save.objects.r data. So now I have saved all the objects that are currently there, which we saw a little while back using ls command. So all these objects are saved in the file name that we just mentioned, save.objects. Now you can remove objects from this list. For example, I want to remove, say, object A and object B. So I can use the command rm and give the parameters, and then if I see the list of objects, then A and B have been removed. I can even remove all objects all at once using rm list equal to, either you can give the list or you can just mention ls. Now it has removed all objects from the workspace at this point. So if you execute the command ls, you will get nothing. But we had saved this data, so we can retrieve our objects from the file that we just saved using the command load file is equal to the file name which we used to save the data, which was save.objects.rdata. Okay, there is some error. Let's see what the error is. Okay, so my file name is wrong. Basically, I had saved it using save.objects, but I am retrieving save.object. Hence, the system is not finding anything. Now I've corrected the file name. Now I should get all my objects back. So let's now discuss about code quality. So what is code quality? It is whether the code achieves its objectives or not, whether the code is free from deficiencies, whether the code is readable, maintainable, extensible or not. A good quality code typically follows coding standards. It is well documented and it is easy to understand and maintain. And finally, a good code is secure. A coding style is made up of numerous small decisions such as understanding the proper use of comments, when to use tabs or spaces for indentation purposes, how can white space be utilized optimally, proper naming of variables and user-defined functions, code grouping in an organization, proper use of patterns, when to avoid certain patterns and which are to be avoided. So all these coding standards or coding styles help us in getting the tasks done in a right and systematic manner. It is highly advisable to write our code in such a way that it improves the readability and makes the software easy to maintain. So without further ado, let's see how to maintain code quality in R. So basically there are two ways of doing this code quality check in R. The first is to use the lint R package, and the second is to enable diagnostics in RStudio. For instance, we have this file as an example. Hello world, concatenation function, learn R programming, greater dot thousand is function, and let us run the lintar package on this piece of file and on this piece of code, and let's see what is the output. So let us set the directory to the directory where our file is stored. In my system it is stored in the D drive, so I have set the currently working directory as D drive, and then we will just write lint first.r. Before running this command, let's if you don't have this library, then you need to download the library or uninstall it, or package as it is called in R, or you can load the library linter. So now I have loaded this library. Now that command is going to work. So this is what the system gives me, that line 1 variable and function name style should be snake case, Variable and function name style should be snake case, again line 2. There should be a space between right parenthesis and an open curly brace. Okay. Put spaces around all infix operators. Okay. There should be a space between right parenthesis and an opening curly brace. This is line 3. Okay. So it says basically we need to have a space here. And then trailing white space is superfluous. So line 5, I have a trailing white space maybe somewhere. Okay, yes, I have a extra white space here. So this is how you can check the code quality of R according to R coding standards using lintar function. So going back to console now. Now let us discuss the second way of checking code quality in R, which is enabling diagnostics. So how do you enable diagnostics? In order to enable diagnostics, you have to go to RStudio, Tools, and then Global Options. Select Global Options from here. Go to Code and go to Diagnostics. Here you can set your system accordingly in order to follow certain coding guidelines, and there are multiple sets of options here. So if you check arguments to our function calls, check usage of assignment operator in function call, warn if variable used has no definition and scope, and so on and so forth. So if you apply after selecting the appropriate options, R will automatically start running diagnostics on your piece of code. Next, let us talk about how to install and load packages. The comprehensive R archive network is marked by thousands of packages which have been developed and released by highly active user base. There are a few functions, datasets, which are required on a frequent basis, and if they are ready to use, it really speeds up the data analysis process in R. These functions and datasets are brought together and made a collection which we call packages. So when we bring all required packages together in a particular directory, that directory is called a library. R has a pre-installed standard set of packages, and it also supports installing additional packages that enhances the functionalities of R. For example, installing the ggplot2 package enhances the plotting functionalities. So to see a list of all the installed packages on your system, you can use the function library. So this has given you all the packages that are present in the system currently. You can get into the documentation of these packages by clicking on the package name, say for Lattice. When I clicked, it took me to the documentation of Lattice package. Okay. Next, let's see if we have XLSX package, which is important to work with Excel files. So we do not have XLSX package. We have ggplot2? We don't have ggplot2 either. So we'll install these two packages. In order to install packages, you need to use the command install.packages package name. So in this case, ggplot2. So let's wait for the package to get installed. So this is how you install a package in R. Let's install another package called XLSX. If you want to load any package, say I want to execute this particular function read.xlsx. So this is present in the xlsx package, but it is not yet loaded. So in order to load it, you need to write library and the package name, and the same command which threw an error earlier will be accessible now. So there is a difference in the error that the system throws. In the earlier instance, it was could not find function read.xlsx, and now it is giving us please provide a sheet name or a sheet index. So now if you want to update the packages, so you can run the function update packages. The system will ask you whether to update or not. You can select yes, yes, yes. So it will update all the packages that are due for an update. Okay, now that all packages have been updated, let's show you another way of updating packages or installing packages. So the second way is you can browse to the tools menu and you can click on install packages or check for package updates in case of updating packages. So when you check this, when you click on this, the system will prompt you to enter the package name that you want to install, and you can install it in the library or any path in your computer. So let's cancel it at this point and let's move to the next topic. So let's now clear the screen. Let's talk about Vignets. So Vignet is yet another way of getting help in R. Vignet provides us with a detailed documentation on packages. So in order to run this function, you need to type Vignet and you need to type say grid and package equal to grid. Now the system is going to give you a documentation in the form of a PDF which will contain all details regarding to the grid package. This is how you use Vignet function. So if you also intend to create a package or a library, then you can do it by uploading your work in the Comprehensive R Archive Network or CRAN network. Now in order to do that, you need to fulfill certain conditions. Your package is going to be rigorously tested on multiple environments before you can upload it in CRAN repository. So for more details, you can Google this. So next we'll talk about datasets. So R has some built-in packages known as datasets which provides us sample data to work with. Now in order to see which all datasets are present in your system, you can use the command data and say data. The system will give you the datasets that are present in the system. So let's reduce the size of this window. Let's move on to the next topic, which is data importing and exporting. R can read from external files stored outside the R environment. It has the capability to work with data in any format such as CSV, XLSX, JSON, etc. The steps to read a file are: we have to set the path of the location to the file's location. To do so, we'll use getWD to uh, know the current directory we are working on, and then we'll use the function setwd. So let's do it. Say we are currently working on C drive, users, MSI, documents. Let's set the part to E drive. So now if we see the currently working directly, the system will prompt E drive. Next, we need to check if library xlsx is present in order to read Excel files, and if it is not present, install that package. If it is present, load that package using library.xlsx, and then there are functions like read.csv, read.xlsx, read.table, etc. to read CSV files, Excel files, and text files. For instance, I have created this test Excel file in E drive of my system. So in order to access this through R, we need to set the working directory as E drive, and then we need to mention a variable in which we can store the Excel files, the values of the Excel file. So we already have the working directory as E drive, so I'll just use the command xlsx and give the file path, which is test.xlsx, and you also need to mention the sheet name, which is sheet 1. Okay, now I can see what is stored in TK. So I got all my values from the Excel file into this variable. Now this was all about importing. R can also write down external files. It can write in various file formats like CSV, Excel, XML, etc. So in order to store data externally, you need to follow these steps. First of all, set the working directory to the directory name where you want to store the file, and then select the object. Say you want to save a vector or a matrix or a data frame, etc., and then use the write command. So for instance, I'll just show you. If I want to write the value stored in variable tk in a CSV file, then I'll write write.csv, and then I'll give the variable name that I want to write and the file where I want to store. So this is example csv.csv, and if I want to write the same thing, say in an Excel file, then I will use the variable, then give the file name, say example.xlsx, and sheet name equal to sample. So this command is going to create a file called example.xlsx. So let's go to our E drive and see if these have been created. So yes, you can find these. Yeah. So let's open this in Notepad. So the system has stored comma separated values of that variable in this file. Now I can open this. System has stored the values of tk in example.xlsx in a sheet called sample. So let's clear the screen now. and move on to our next topic. So many times it might happen that you might run into errors. Say if you are trying to read a file which does not exist in the given location, then the system is going to throw an error. So in such cases, you can use logical operators, like for instance, I want to check if file exists, say data.csv, and if it exists, only then it should read csv data.csv. So this statement is not going to throw you any error. But had we written, say, x assignment operator read.csv data.csv, then the system would have run into error stating that it did not find data.csv in the current file or directory. Next, let's talk about mathematical operators. Operators in R can be categorized into arithmetic operators, relational operators, logical operators, and assignment operators. Say I write x equal to 87, y equal to 83. So this is the addition operator. So if I write x plus y, it will give me the sum of x and y. Now there is a subtraction operator. X minus y will give me the difference between x and y. Then we have the multiplication operator. X into y will give me the product of x and y. Then we have division operator. X divided by y will give me the division, give me this value. Then we have modulus operator, which will give me the remainder when x is divided by y. Then we have integer division operator, which is x percentage slash percent y. This will give me integer division. And then I have x exponent operator, which will give me the exponent of x and y, which is nothing but 87 raised to power 83, which is a very huge number. So these were the arithmetic operators present in R. Now let's talk about logical operators. Say I create two variables, x and y, in which I give these values, c, true, false, false, and true. And let me create another variable in which I'll give values true, true, 0, and 1, 4. Now this is logical not operator, exclamation sign and x. This will perform the not operation on our variable x and give you the result. So for true, false, false, true, you will get a result false, true, true, false. Now next talk about logical AND operator. So if you type x and y, it will give you element wise logical AND. So if you remember, x was this, y was this, and true, true gives true, false, false, true gives. Okay, moving on to next operator, which is logical AND. This you can get using x and y. It will give you true. In this case, you can have logical OR operator. Logical OR operator will be x or y. So this was the element wise logical OR operator. Now let's talk about logical OR. This is just x or y. Let's talk about assignment operators. So we have two types of assignment operators, namely leftward assignment and rightward assignment. So leftward assignment can happen like this. Say if you want to print a, it will give you 19. You can also do leftward assignment using double brackets like this, and it will give you the same result. Now you can have rightward assignment, something like this. And just like leftward assignment, you can use double brackets like this. You can print, you'll get this result. Finally, we have relational operators. Let's clear the screen first. Say if I declare a variable 1 as 21 and variable 2 as 89, then I can have variable 1 less than variable 2. This is less than relational operator. I can check if variable 1 is greater than variable 2. This is greater than relational operator. I can check less than equal to, similarly less than equal to variable 2. Similarly, I can check greater than equal to, whether variable 1 is greater than equal to variable 2. So these are very basic stuff. I'm just covering them for the sake of covering. So these will be used basically when we'll talk about functions and when we'll talk about loops, etc. These operators are going to come in very handy. So to check if variable 1 is equal to variable 2, and this is how we check whether variable 1 is not equal to variable 2. So that is all about operators. Now let's move on to our next topic, which is strings. So let's create a variable, say variable 1, and assign it a string. Welcome to Insane Coders R tutorial. Now let's use the substring function. So in order to see the syntax, for instance, you want to see the syntax of substring function, you can use str function and give the substring function. It will give you the syntax of the function. So x is the character vector, start is the integer or the first element which is to be replaced, or the first element which is to be extracted. In this case, stop, it is again an integer and it is the last element to be replaced or extracted. For instance, I want to extract say substring var1, and I want to extract from 8, 9, 10, 11th character till 20th character in the string. So the system gives me the extracted string, which is insane space cu. You can even replace characters. For instance, if I want to replace, say, from 12th till 18th, I want to replace and insert, say, spring in this. So I'll just type in this. I'm sorry, it's not X but substring var1 12 to 18, and I want to replace it with say spring. Now if I print var1, it will be welcome to Spring Coders R tutorial. So this was the substring function, which can be used to extract a substring from a string, or we can also use it to replace a substring within a string. Now there is another function called CHRTR. So let's first of all see its syntax using str CHRTR. I'm using str function time and again because it's a very handy function, and so this is the syntax of CHRTR, and now this can be used to replace, say I want to replace all E characters with say dollar in our variable var1. So the system automatically replaces all E's with dollars in var1. Next we will discuss about grep function. So for instance, we have a variable 2, which has a lot of strings within it, say Monday, Tuesday, Wednesday, Thursday, Saturday, and then finally Sunday. Now if I want to say search for a pattern here, say I want txt variable in which I want to see pattern equal to r day in var2, then txt will show me 6. That is only the sixth string of this object has the pattern rd. Similarly, if I wanted say grep pattern is equal to day in var2, the system would return all the days, because as you know, day is a part of all the days. It is a lame joke, please don't laugh. Now there is another function called gsub, which can be used to substitute a particular pattern with another pattern. For instance, say gsub, let's find pattern equal to day, to which I want to substitute it with say way in var2. So now the system has substituted day everywhere with way. So now let's clear the screen. There is another class of objects called dates. So for instance, I enter a date in character format. Let's enter 2020 0702. Now if you see the class of this object, it will be shown as character. Now you can convert this variable into date class using the function as.date. So now if you see the class of date variable, it will be date, and if you just print the date variable, it will print 2020-0702. The default format of date in R is YY-MMDD. Basically this. Now R has a default function which is sys.time. If you want to check the system's time, then it will show you the system time. If you want to check the system date, it will show you the date of the system, and if you want to see the time zone, then it will also show you the time zone of your system. So finally, this object sys can give you a lot of variables which can be used in your programming, like set local, sleep, time, umas, calls, load image, etc., etc. So it's a pretty handy object. So you can research more on this after this tutorial. This is what we are going to cover about sys object in this tutorial at least. Next we'll move on to functions. So let's clear the screen and let us create a very simple function of sum of variables. Say this is a function to which I pass the parameter x, and let's create a variable y in which I'm going to store the sum of x basically, and this function is going to return y. Now let's say I have marks and I want to use my newly created function, so I'll just pass sum var marks and it will sum all the elements of marks and give me the total of 89. So this is how you create a custom function. So basically a function is a set of statements which is organized together to perform a specific task. R has a large number of built-in functions, and also the user can create their own functions. R has the ability to create custom functions, and in order to create a custom function you need to use the function command. And R has an interpreter which is able to pass control to the function along with arguments that may be necessary for the function to accomplish the actions. And finally the function performs its task and returns control to the interpreter, as well as any result which may be stored in any other object. So like any other language, R also has loops. For instance, let's say a is 5, and let's use while a is less than 10, I want to print I am in a loop, and let's say a is equal to a plus 1. Let's close this loop and press enter. The loop runs for 5 times. Basically, if you want a basic course in loops, I would refer you to some basic course of Java or C. At this point, I'm not going to get into loops a lot. I'm just going to show you how loops work in R and what is the syntax of loops, and that is it. Similarly, we have for loop in R. So for I in 1 is to 10, print education should be free. So the system is going to run this loop for 10 times and then end it. Let's clear the screen. And now let us move on to apply functions. These functions are specific and are pretty interesting. So R has multiple apply functions, for example, apply, lapply, sapply, etc., which facilitates us in working with huge data sets. So let's create a data frame. Say math scores for 23, 32, 12, 32 and 21. Say science scores are something like this. Say history scores are something like this. And let's create a data frame df1 using data.frame math, science and history. Let's print df1. It will give math, science, history scores, and let us give our row names. Of df1 would be C, person 1, person 2, person 3, person 4 and person 5. Now let's print df1. So it's a proper 3 cross 5 matrix with us, data frame basically. And now we'll apply functions onto this data frame. So if we want to use the sum function to get the total marks scored by each person, then we'll have to release something like this: list sum, and then we'll have to give df1 1 comma. Similarly, we'll have to give sum df1 2 comma and sum df1 3 comma. So this gives us the sum of the first 3 persons. We can just increase it, add more pieces of code here to get the sum of all 5 persons. Now if I want to do the same thing using, say, apply functions, then what would I do? So I'll use the apply function on df1. 1 is for row and 2 is for column. So I want per person's sum total of scores and various subjects. So I'll use rows or 1 and then the function that I want to use, sum. So it gives me the total score of each person. Similarly, if I want to see the sum of scores of various subjects, then I can use 2 in place of 1. This gives me the total scores in various subjects. Now let us talk about lapply function. Lapply only works on columns, unlike apply, which works on both columns and rows. So if I use lapply, then I'll have to give df1 and the operation that I want. Then it is going to do that operation, in this case sum, on every column of my object and return me the values. Similarly, there's another function called sapply, in which you can mention this and it will return values in a simplified form or in a matrix form basically. So um, when the results are all scalars, sapply will return a vector, and if all results are of same length, then sapply will return a matrix with a column for each element. So lapply has returned me a list, but sapply has returned me a matrix. This is the main difference between lapply and sapply, which is very important from an interview perspective, by the way. Apart from sum function, you can also perform mean function. For example, sapply df1 mean. So it will give you the mean of various subjects. Similarly, you can find range in various subjects using this function. So the range of scores lies between 12 and 32 in case of math. In case of science, it is 12 and 43, and in case of history, it is 12 and 54. Now, in case you have categorical variables, that is, you have some non-numeric variables are called categorical variables. This is another information which is pretty handy when dealing with data science related problems. So if you have data categorical variables, then the function tapply comes into use basically. So sapply, lapply will be applied basically on vectors and matrices. Like matrix is also a vector. So in case you have categorical variables are variables which are non-numeric. So this is a very important piece of information in dealing with data science related activities. So in those cases, you will use the function tapply. Tapply, say df1 $math, df1, and you want another df1 $science, and you want the average, that is mean of these two columns, then you can use tapply. So next, let us talk about a package called Profis. So Profis is a tool used to visualize code profiling data in R. So it generates a web page which would provide us a GUI for understanding the time taken to execute a piece of code. So let's see. First of all, let us install this package. Let us load this package. So let us consider a data set which is already present in R, diamonds. The name of the data set is diamonds. So if I say, sorry, this is in ggplot2, so I'll have to load the package first, and then I would be able to use this data set diamonds. Okay, so now I'm good to go. So for instance, I want to check the efficiency of a loop or an apply function that we just now discussed. So for instance, I want to calculate the mean of the caret and the price column. So if I use a loop, then I'll have to declare, say, two variables. Let it be mprice and be it caret. And then let us write a function for I in length of diamonds price. Let's open the curly brackets. M price is equal to sum of M price equal to sum D diamonds dollar price I and then let caret be equal to sum of caret times dollar caret I. Then let's close this. Now let's print imprice by length diamonds dollar price, and let's print caret by length diamonds dollar caret. And let's do the same thing using apply function. Diamonds C17 to mean. It gives you the mean of column 1 and column 7. So I'll just clear the screen. So we got the mean using a loop, and we got the mean using apply function. Now let's see the efficiency of both of them. So in order to calculate the efficiency, you can use profvis. Say, let's open this bracket and we can have data of diamonds from package ggplot2. Let's declare mprice as null, caret as null, and let's run the loop for I in 1 is to length of diamonds price. I'll start the loop here. M price should be equal to sum of M price diamonds dollar price I, and caret is equal to sum of caret diamonds dollar caret I, and let's close the loop and let's calculate M price by length of diamonds price and caret of length diamonds price. Now let's close it. Profvis is running in the background and it shows you the result. How much memory it used, how much time it used. So it has profiled. Now next, let us use Profvis to check the efficiency of our apply method. So this data diamonds package ggplot2, and let's apply the apply function, which is diamonds C1,7. I want this to be done column wise and I want the mean. Let's close this. So now you can compare how much memory did our apply function use and how much memory did the loop use. So not only the apply function used less amount of memory, but it also was executed in a fraction of time in which the loop was executed. So basically the purpose of this exercise is to demonstrate how efficient apply functions can be when working with large data sets. So just imagine if it had it been 30 times 40 times greater than our current data set, then the time taken by the for loop or any other loop would have been bigger, and at and in such cases apply functions become very efficient. So that leads us to our final topic of this introductory R course, which is visualization. So let's open our console back. Let's clear the screen, and we'll be discussing about the basic visualization methods present in R, which are histograms, bar line chart, box plots, scatter plots, and dot chart. So basically, the advantages of plotting data is it captivates new information and it is helpful in identifying patterns and identifying new trends. So data science ultimately leads to these kinds of visualization methods. And so let's start with histograms. So there's a data set called discoveries. This dataset gives us the details of the greatest invention in each year from 1860 to 1959. So now we can view this data in histograms using hist command, in which we'll give the dataset's name, we'll give the number of breaks that we want. So what the system is going to do, it is going to divide the entire range into that number of breaks. For instance, say we want 10 breaks. So if there are 100 years, then it will be divided into 10 ranges, 0 to 10, 10 to 20, 20 to 30, and so on. Then we'll give, say, a color. Let's give it greens. Histogram of discoveries data set. Okay, so let's make it green. Basically we could use a brewer panel, it will give different shades of green, but at this point, because it's not working, so let's work with a single shade. So this is how a histogram works. So next, let us move to line chart. Line chart is normally preferred when analyzing trends over a period of time. So to demonstrate line chart, we'll use the trees data set. So say trees, you get head of trees. Let's see, what does it give? It gives the girth, it gives the height, and it gives the volume. So let us see, let us apply this plot on trees dot height. So we'll apply it on height of the tree, then we will write type. So type is like character string gives the type of plot desired. L is for lines, P is for points, B is for both points and lines, C for empty points, and so on and so forth. For this demonstration purpose, we are going to use L, type equal to L, and color, let's say, equal to red. I'm sorry, it should be red. So now let us move to our next data visualization, which is bar plot. So for this we will activate mass and use one of the datasets in this library called painters. The painters dataset from mass package gives us the details of painters from different schools. So let's see, doesn't painters. So basically this kind of data this particular dataset has, and we'll use it to plot our bar plot. So let us create a variable in which we are going to store the school of painters dataset. Then let's create a table out of it, and let's create a bar plot. Sorry, it should be topo colors. Okay, so this is how you create a bar plot. Next, let us discuss about box plots. So for box plot, we'll consider the iris dataset. So you can see, so iris dataset gives us the measurement of variables sepal and petals length and width for 50 flowers from each of the 3 species of iris. So you can use box plot iris sepal dot length, iris dot sepal dot length, iris species, color equal to red. So it gives the box plot for sepal length for various species of iris. Next, let us move to scatter plot. Scatter plot gives us a visualization of data in geometric points. So let's clear the screen and let's plot the trees data set. Say let's use red. To 16. So this plot gives us data with the help of geometric points, and we can analyze girth versus height in using this graph, girth versus volume using this graph, height versus volume using this graph. Say I want girth on the y-axis and height on the x-axis, then this graph works. So it gives us a variety of geometric graphs to work upon. So these are the basic data visualization types in R. You can install packages like ggplot2, which has even a wider variety of plots. So with this, we come to an end to this introductory course of R. This is a very essential course for you to complete in order to go further in your aspirations of becoming a data scientist. So before winding up, let us just try to give you the advantages of our language. So basically, the biggest advantage of our language is that R is an open source cross-platform language which can run on many operating systems. In fact, I've run it on almost all operating systems, including Mac OS and Linux and Windows, which are the major operating systems, obviously. And it runs on both 64 and 32-bit processors. It supports a lot of extensions, and it has a very active community. R very easily connects with other languages, and it has very good graphical capabilities. In fact, languages started developing graphical capabilities only after the introduction of the variety of graphical capabilities that R had introduced. It has over 10,000 packages which are available from multiple repositories, and it specializes in topics like econometrics, data mining, spatial analysis, and bioinformatics. So, if you want to pursue your career in any of these fields, R becomes an essential thing for you to. And I hope that our introductory course will be useful in your aspirations of in becoming a data scientist. So we discussed about objects and classes. We discussed how to install and load packages. We also discussed and demonstrated how to import and export external files in R. And we discussed about apply functions and how to apply mathematical data and strings. And finally, we concluded by demonstrating the various visualization techniques, the basic R visualization techniques. So with this, we come to the end of this course. If you like this video, please subscribe to our channel for similar videos that we will put on data science and other computer science areas. See you till then. Thank you.